In earlier classes, we have learned how to perform the operations of addition, subtraction, multiplication, and division on numbers. Each one of these operations was performed on a pair of numbers to get another number. Similarly, there are some operations which, when performed on two sets, give rise to another set. We will now define certain operations on sets and examine their properties. You are in Mathematics of Engineering. Let A and B be any two sets. The union of A and B is the set which consists of all the elements of A and all the elements of B, the common elements being taken only once. Symbolically, we write it as, where we read this as A union B. The equation implies all the values of x where x belongs to A or x belongs to B. So, the union of two sets A and B is the set C, which consists of all those elements which are either in A or in B, including those which are in both. From the example, the union of sets A and B are the elements 1, 5, 6, 7, and 9. Consider two sets A and B where the elements of A are the vowels A, E, I, O, U, and set B would have the vowels A, I, and U. This example illustrates that the union of sets A and its subset B is the set A itself. That is, if B is a subset of A, then the union of A and B is just equal to A. Similar to the different properties of operation in arithmetic, there are different properties of operation of union. First is the commutative law. This states that the union of sets A and B is equal to the union of B and A. This is shown that regardless of which set comes first in the equation, the totality of elements are still considered. The second property is the associative law, which states that the union of set C with that of the union of A and B is equal to the union of set A with that of the union of B and C. The third is the idempotent law, which states that the union of the set A is just set A. Next property is the law of U, which states that the union of the universal set U with that of set A is just equal to the universal set U. The last property is known as the law of identity element, where null is the identity of union. It states that the union of set A with a null set is just equal to set A. The intersection of sets A and B is the set of all elements which are common to both A and B. The inverted U is used to denote the intersection. The intersection of two sets A and B is the set of all those elements which belong to both A and B. Symbolically, we write it as, where it would mean all the values of x where x belongs to A and x belongs to B. In this example, the intersection of sets A and B would be 9. Let's consider sets A and B. We let A have the elements 2, 3, 5, 6, 7, and 9, and set B would have 2, 3, 5, and 7. Find the intersection of sets A and B. We have the intersection of A and B as 2, 3, 5, and 7, which is equal to set B. We note that B is a subset of A, so that the intersection of A and B is just equal to set B. If A and B are two sets such that the intersection of sets A and B is null, then A and B are called disjoint sets, because there are no elements which are common to A and B. Similar with the operation of union, There are some properties of operation of intersection. First is the commutative law. This states that the intersection of sets A and B is equal to the intersection of B and A. For the associative law, it states that the intersection of C with the intersection of sets A and B is equal to the intersection of A with the intersection of sets B and C. The third property is the law of null, which states that the intersection of null and set A is just equal to null. Consequently is the law of U, which states that the intersection of a universal set U and set A still equal to set A. The next property is the idempotent law. It states that the intersection of set A with another set A is just equal to set A. The last property is the distributive law, that is, intersection distributes over union. It states that the intersection of set A with the union of sets B and C is equal to the union of the intersection of sets A and B and the intersection of sets A and C.